Good morning. Consider the following transfer function. G of s is equal to 4s square plus 2s plus 5 by s cube plus 10s square plus 31s plus 30. So obtain the state space representation of the system in diagonal canonical form. So to obtain the diagonal canonical form, we perform the partial fraction of the given transfer function. So perform partial fraction of the given transfer function so factor of the denominator. We have to find the factor of the denominator. So denominator is s cube plus 10s square plus 31s plus 30. So by using the synthesis division method, we can find the factor or the roots by the testing small integral reverse. So for example, this is 1, 10, 31, 30. So let us check by substituting s is equal to minus 2. So it is a 1, minus 2, 1 is a minus 2. This is 8, 8 to the 16. So it is a 15 and 15 to the minus 30. So it is 0. So the roots for this equation is like this. We can write the roots for this. The roots are this s plus 2 and this s square plus 8s plus 15. Okay, again we can find the roots of this. So this is s plus 2 and the roots of this is s plus 3 plus s plus 3 and another is s plus 5. So these are the roots of the denominator. Now partial fraction expansion. Partial fraction expansion. So g of s is equal to 4s square plus 2s plus 5 divided by s plus 2, s plus 3, s plus 5, and this we can write like this: a over s plus 2, b over s plus 3, and c over s plus 5. Okay, now we have to find the values of ABC. So solve for the residues ABC. So just I will show you how to find. For example, A is 4s square plus 2s plus 5 divided by this. A value of A is this: s plus 2, s plus 3, s plus 5, and this is s plus 2. So we have to multiply it by s plus 2 because the denominator is s plus 2. So the value remain will be 4s square plus 2s plus 5 divided by s plus 3 by s plus 3 into s plus 5, and this put s is equal to minus 2. Put here s is equal to minus 2. If we put s is equal to minus 2, so minus 2 is 4, 4, 4 is 16, minus 2, this minus 4 plus 5 divided by minus 2 and plus 3 it is 1, and minus 2 and 5 it is 3. So we get here 17 by 3. Okay, we get here 17 by 3. Similarly, we can find the values of B and C. So B is, very quickly we can write down, B is 4s square plus 2s plus 5. Now the denominator s plus 3, so s plus 3 will be cancelled. What will remain in the s plus 2, s plus 5, and as the denominator is plus 3, so put s is equal to minus 3. S is equal to minus 3, and if you put here s is equal to minus 3, we'll get 4, 3, 3 is 9, minus 6 plus 5 divided by minus 1 and 2. So we'll get here minus 35 by 2. Okay, we'll get this value, and you can, I am directly writing the value of C. C will get, again just write down this, and divided by, what is the coefficient, denominator factor is s plus 5. So s plus 5 will get cancel. What will remain here? S plus 2, s plus 3, and here we put s is equal to minus 5. Put s is equal to minus 5, and we'll get 4 into 25 minus 10 plus 5 divided by minus 3 into minus 2. Okay, if you find, we'll get the values 95 by 6. So this is the value we get. Okay, now we have to find the, now we have got the values of A, B, C. Just put g of s is equal to 17 by 3 into divided by s plus 2 minus 35 by 2 divided by s plus 3 and 95 by 6 divided by s plus 5. Okay, so the state space, now by using this residues and poles, the diagonal canonical form, we can write x dash of t is equal to a into x of t plus b into u of t. So, and y of t is equal to c into x of t plus d into u of t. Okay, so we have to write this x dash is equal to x1 dash, x2 dash, and this x3 dash. In matrix form we can write here, what is the pole? Pole is minus 2, 0, 0 of this 0, minus 3, 0 diagonal matrix. Then next is the 0, 0, it is a minus 5, matrix complete. This is x1, x2, x3 plus, as per the standard form, 1, 1, 1 into u, and values of y is equal to residues. We have got 17 by 3 minus 35 by 2 and 95 by 6. So we have to write this residues, that is 17 by 3 minus 35 by 2 and 95 by 6, and this is x1, x2 and x3. So this is the diagonal canonical form of the given transfer function. Thank you very much for watching the video.